Hello, welcome to my channel. From today, I will make a series of videos about solving the integration problems for MIT Integration B. On their website, they only post the paper for the qualifying round there. And the earliest date available on their website is 2013. So, we will start from 2013 MIT Integration B. There are totally 25 problems. In this video, I will solve from problem 1 to problem 5. So here is problem 1. So problem 1 is about the integral on the log functions. For the first term, we can put the power index in front of the log function by using the property 1. For the second term, we can split it into the sum of log 2 and log x by using the property 2. Next, we just expand it. Then we found the first and the third term can be cancelled out. So we got a constant inside the integral. If you like, you can put the 2 inside the log function. And we got log 4. And then we can take the log 4 out of the integral. So here is our final answer. And don't forget to put the constant c there. Now let's look at problem 2. For problem 2, the key is to deal with the absolute function, the absolute x. Because this integral is from -1 to 3, but we know the absolute x will change the sign at the 0. So we split it into two terms for this integral. So the first term is start from -1 to 0, and the second term start from 0 to 3. For the first term, since x goes from -1 to 0, so x takes negative values, then we can replace the absolute x by using negative x. For the second term, x goes from 0 to 3, so x always takes positive values. So we replace the absolute x with x. Next, we just integrate it, plug in numbers, and simplify it. So here is our final answer. Now let's look at problem 3. By a first look, this one is complicated. And if you are sensitive to the quotient rule, maybe you can use it to solve it directly. And then you can skip all the steps directly to the final answer. But if you are not very sensitive to the quotient rule, then we just follow the normal procedure. First, let's rewrite it into two terms. Pay attention on the term inside the red box. So this term is the derivative of 1 over log x. Then we can replace this term by the derivative of 1 over log x. Next, we can rewrite cosine x as the derivative of sine x. So now we are ready to use a product rule. And here is the final answer. For problem 4, it looks simple. And you have two ways to do this. The first way is just to integrate term by term, but this one will be time consuming. For example, for the first term, if you integrate it, you will get 1 over 4 times x to the power 4. And then if you plug in numbers, the result will be a very large number. And then you need to simplify it with the result of other terms. A smart way is to simplify it first. And the function inside this integral can be written as a complete cube. Then we replace it as a complete cube. So we can immediately get the result. And then we plug in numbers and simplify it. And here is our final result. So you can see if we simplify it at the very beginning, it can save us a lot of time. For problem 5, it deals with the integral respect to a square root function. First, let's take out the square root 3. Next, we can do this by substitution and let x equals to 2 times sine theta. Or you can let x equal to 2 times cosine theta. But this is not a very good way to solve it. The best way to solve it is to use the geometry. If you look at the graph for this function y equal to square root 4 minus x squared, the graph is just a half circle above the x-axis, And this integral goes from 0 to 2. So that means it calculates the area of a quarter of the circle. So by geometry, we can get the answer immediately. For the area of the quarter of circle, it's just 1/4 times pi r squared, and the radius here is 2. So we get the result immediately, which is square root 3 times pi. That's all for today. I will solve other problems in the next video. Thank you for watching. Please subscribe my channel if you like it.